Hey everyone, welcome back. Today we are diving into some Numpy practices. Whether you are a beginner or just want to brush up, these exercises are a great way to get comfortable with Numpy. So let's do it. So first up, let's import Numpy under the name NP. We'll use this shorthand NP throughout the video. It's a common convention and keeps our code cleaner. Okay. Now let's check the version of NumPy we are working with and see its configuration. This is mainly useful if you are troubleshooting or comparing codes across different versions. For this. Next we are creating a null vector of size 10. A null vector just means a vector filled with zeros. This is one of the simplest way to create an array with default values. Now let's find out the memory size of an array. This can be helpful with when dealing with large data sets. Here we are multiplying the array size by its item size to get the total memory in bytes. Here it's 800 bytes. Let's create another null vector of size 10, but this time we'll set the fifth value to 1. And this shows how to access and modify specific elements in a NumPy array. Now let's make a vector with values ranging from 10 to 49. The arrange function is great for creating sequences in just one lines. Next up, reversing a vector so that the first element becomes the last. This neat trick uses Python slicing to reverse the order. Now let's create a 3x3 matrix with values from 0 to 8. Here we are using reshape to organize our values into 3x3 grid. Now we'll find the indices of non-zero elements in this array. This is useful when you want to locate specific values in an array. Then let's create a 3x3 identity matrix. This is a matrix with 1s on the diagonals and 0 elsewhere. Identity matrices are common in linear algebra and machine learning and all. So yeah, this is important one. Now then let's create a 3 into 3 into 3 array with some random values. And yeah, using randoms lets us quickly fill an array with some random numbers we want. Then let's move on to creating a 10x 10 array with some random values. Then finding the minimum and maximum values. Getting mean and max values is helpful when you basically analyzing your data sets for your model, etc. Next, we'll create a random vector of size 30 and find its mean value. So here in this case it will be 0.576, and every time this value will change because we are selecting random values. So calculating the mean is common in data analysis to understand the average value scenarios and all those cases. Then let's create a 2D array with 1 on the border and 0 inside. This is a simple way to set up a border matrix, which is very important for training and further our data analysis. Now let's add a border of zeros around an existing array. Yeah, the particular pat function is super flexible for customizing this type of borders. Finally, let's look at some expressions involving NaN or not a number, which has some special behaviors. Okay, so NaN can be tricky. Here, some of the examples are you can see that NaN does not equal to itself, and comparison involving NaN don't always behave as we might expect. Floating point math quirks like 0.3 is equals to 3 in 3 multiplies 0.1 returning false happen due to some rounding errors. Let's create a 5x5 matrix with values 1, 2, 3, 4 just below the main diagonal. Here we are using np.diag function to place our values below the diagonal by setting k is equals to minus 1. This trick lets us control where we place values within the matrix. Next, we are creating an 8x8 checkboard matrix. We are using slicing to create the checkboard pattern by filling specific cells with ones. This is a great way to practice array indexing, by the way. Now let's consider a 3D array with shape of 6, 7, 8. We will find the index xyz of the 100th element. The unravel underscore index function helps us find the position of an element in a multidimensional array when we know its 1D index. Next, let's create another checkboard of 8x8 matrix using the tile function. With np.tile function, we can easily repeat a pattern to build a checkboard layout in just one line. Now let's normalize a 5x5 random matrix. Normalizing means adjusting values to a common scale. Okay, so let's run it. Okay, so here we subtract the mean and divide by the standard deviation, transforming the matrix so it has a mean of 0 and standard deviation of 1. Now let's create a custom data type that describes the color as 4 unsigned bytes representing RGBA values. Okay. Now if I print this, this custom dtype defines each color component as an 8-bit unsigned integer, which is standard for RGBA color data. Now let's multiply a 5 into 3 matrix by a 3 into 2 matrix to get a real matrix product. So here we can use the np.dot function to perform this matrix multiplication. Next, we'll negate all elements in a 1D array that are between 3 and 8 in a place. So we will be using Boolean indexing here to identify and change only the values we are interested in. Now here is the fun one. Let's find the output of this following script. Okay. So in the first case, Python's built-in sum function will output 9. So let's run this first. Yeah. In the first case, Python's built-in sum function will output 9. In the second case, np.sum adds an axis parameters of -1, summing along the last axis instead. So that's why we'll be getting the value 10. Number 27. Now consider an integer vector z. Which of these expressions are legal? Okay. So these are the expressions. Here, the first, second, third, fourth, fifth. These 5 are all legal. But however, the last one is not, because this is not a valid chain comparison as per Numpy. Okay. Then let's find out what are the result of these following expressions. If we run it, okay, we get NaN mean not a number for division by 0 in the first, an error for integer division by 0 in the second, and finally a surprising minus 9.22337 epsilon plus 18 for casting NaN to integer and back to 4 in the third. Okay. Now let's round away from 0 to float array. Okay. Using np.copySign with np.seal ensures we round values away from 0, maintaining the original sign. and on the below it will be much more readable but less efficient if we use np.where with np.seal function. Then to find the common values between two arrays, we use the intersect 1D function. Okay, the commons are 0, 6, 7. Function finds and returns the shared values between these two arrays. Now here is how to ignore all numpy warning. So this will be our suicide mode. This will be our back to sanity mode. This is to equivalently with the context manager. Okay. Um, these are just some basic thing that you should be aware of. You don't have to really get into the details of this. Okay. Now in this expression, is the following expression true? The answer would be false. It's false because np dot sqrt minus 1 gives not a number, while np dot emath dot sqrt minus 1 gives a complex number. So it will never be true. Finally, let's get the dates for yesterday, today, and tomorrow. So let's run it first. Then if I just print all the values, if I just print all the values, so we'll be having 3. So 1st of November, 2nd of November, and 3rd of November. Okay. So keep practicing these basics and don't forget to like, subscribe, and tap the bell if you want to keep learning with me. I'll be sharing my learning experience here with all of you, and I'll see you in the next one.